Hello everyone, this is Mr. Appel, and today we're going to look at some special kind of factoring, sum and difference of cubes. So I want to first take a look at a couple problems that you should already kind of know how to do. But if you look at this first thing here, this a plus b all raised to the third power, hopefully by now you are no longer going to make the mistake that some make, which is to think, oh, I can just distribute that and do a cubed plus b cubed. Wrong answer. Thanks for playing. Don't ever do that. Remember that raised to the third power means the entire thing is raised to the third power. So it's that entire thing times itself 3 times. And so you've got to do a bunch of distributing. So if you take, let's just say the second and the third one and distribute, the first a plus b is going to stay home. Then we have a squared plus ab plus another ab, so that's plus 2ab, and then plus b squared. I'm going through this quickly, but if you want to kind of do it for yourself, you might want to pause and do it for yourself. Now we got to distribute each of these terms to each of those, so we're going to have 6 terms. A times a squared is a cubed. A times 2ab, that's 2a squared b. I'm just going through this quick. Plus ab squared plus a squared b plus 2ab squared plus b cubed. And then we've got some like terms we can combine. We've got our a cubed, a squared b, 2a squared plus 2a squared b plus a squared b is 3a squared b. ab squared plus 2ab squared is 3ab squared, and then the b cubed. And so all of that was just to confirm that a plus b to the third power is not a cubed plus b cubed. It is this ugly mess. So if we're trying to, what we're really interested in is factoring something like a cubed plus b cubed, right? Working in reverse. So clearly it's not that. So the question is, what is it? Well, the short answer is it's this. And just to show you that that's true, let's watch what happens when we multiply this whole thing out, when we distribute there. So a times the a squared gives us our a cubed. A times the negative ab, that's a minus a squared b. A times b squared, that's a plus ab squared. And then distribute the b. That's b times a squared, or a squared b. B times the negative ab, that's minus ab squared. And then plus the b cubed. And then what we see is the minus a squared b and the plus a squared b cancel out. The plus ab squared and the minus ab squared cancel out. And we're left with a cubed plus b cubed. And so all of that is to say, what you need to know, and really this is kind of one of those things you just sort of have to memorize, is that a cubed plus b cubed is a special kind of factoring, something cubed plus something else cubed, and it looks like this. It's the a plus b, and then a squared minus whatever a is times whatever b is, plus whatever b is squared. And that's how you can factor a sum of cubes. Now the difference of cubes, when you have a cubed minus b cubed, the good news is all the terms look exactly the same. It's an a and a b, and then an a squared, and then an a times b, and then a b squared. The only difference is, because this one is minus, the first term is minus, and then the rest are positive. So each of them only has one minus in it. If you look at the 3 signs, 1, 2, 3, when it's a cubed plus b cubed, the minus comes second. In the a cubed minus b cubed, the minus comes first, but otherwise they're the same.